Hello everyone. Today I am going to walk through you our project, the Mental Wellness Tracker. Myself, Sadman Sakib Apurvo, ID 1451, Department of Software Engineering. This is a full-stack web development application built to help users track their mental health through mood logging, goal setting, journaling, and AI-powered chatbot. Our This is a project overview that we have established. The problem we have faced that user struggles to constantly track daily moods. Manual journaling is inconsistent and offer no visual insights over. The solution we have been discovered that a digital system to record, store and visualize mood data with reminders, goal tracking and a supportive chatbot. Here is our stakeholders and requirements that we have made, and this is the system architecture: front-end layers, back-end layers, database layer, and external API. This is our use case diagram. We have spread it through 3 pages for our full authentication, and the first part is for authentication and mood entry. Second part consists of mood history, visualization, and goals, and the third part is reminder, chatbot, and admin. Functional requirements and non-functional requirements, we have gave the same amount of time for these two requirements to our performance, security, and usability and reliability. Next, our actors and role. Users can create, manage, and personal account, view mood history, visual charts, set and manage reminders, receive motivational messages. For admin panels, approve registers and deactivations, monitor system and performance, ensure compliance with privacy standards, resolve technical issues and completely. This is our ER diagram. Technology we have used for this a front-end for HTML CSS with JavaScript and Chart.js. For backend we have used Node.js with Express.js and JWT by Grips. For database MySQL and XAMPP. For AI Gemini AI API and VS Code for overall environment. Quality assurance and testing that we have done regarding this project, and this is the technical issues and solutions we have found for this. Now let me start by showing you overall structure of the project before we dive into each file. Our project located at D drive inside the mental wellness tracker folder. Inside we have two main parts, the backend folder and the frontend folder. The backend run on Node.js with Express on port 5000. Server.js is the main entry point that start the server. Router folders contain all our API root files, config folder, database connection setup, .env files, store secret credential like database password and Gemini API. Git ignore prevents sensitive file from being pushed to GitHub. Package.json and package.log.json manage all our dependencies. Our frontend folder, the frontend is plain HTML, CSS and JavaScript running on live server at port 5500. Inside frontend, we have all our HTML pages, a CSS folder with main CSS, header and CSS and footers.css, JSS folder with one JavaScript file for each page. Now, for backend file, server.js. This is the heart of our backend. Let me open it. At the top we open import express cors.env and all our root. We call .env config to load environment variables from the .env file. Then we set up middleware express.json to praise incoming JSON data and cors to allow our frontend on port 5500 to communicate with other backend port on 5000. Then we register each route with a base path. For example, /API/authenticate handles login and registration. Then /API/mode handles modes entries, and so finally we tell the server to list it on port 5000. For config.db.js, this file set up our database connection using our MySQL 2 library. We create a connection pool using the credentials stored in our .env file and database host, user, password and database name, which is a mental wellness tracker. Using a pool is better than a single connection because it handles multiple requests efficiently. .env file. This file contains all our sensitive information: DB host and DB user, DB password, DB name, JWT secret and authentication tokens, and Gemini API key for the chatbot. This file is never pushed to GitHub thanks to our .git ignore. Package.json. This file defines our project and lists all dependencies: express mysql to JSON web token, bcrypts curs, .env and node.fetch. These are the libraries our backend needs to run. Packagelog.json. This is where auto-generated by npm. It logs the exact version of every package installed to so that anyone who clones the repo gets the exact same package. We never edited this manually. .git ignore. This tells Git with what to ignore. We ignore node modules because it's huge and can be reinstalled. .env because it consists secret credential we don't want on GitHub. Now for the routes. For the mode, we have this handles all our mode related operation. We have route to add a new mode entry with a score from 1 to 10 and an optional note to get all the mode history for the logged in user. Update a mode note and delete a mode entry. Every root user our authentication middleware to verify the JWT token so only the logged in user can access the own data. Router.node.js. This handles sticky notes. User can create notes with content and color. We support 5 color options. For our goal, this message wellness goal, user can create goal with title, category, for target value and current progress. Reminder.js. This handle reminders. User can set reminders with a title, message and time. The frontend uses the data to trigger alarm pop-up with sound snooze for 5 minutes or dismiss option. For chatbot, this is our AI chatbot route. It receives the user message, sends it to the Google Gemini API with our API key from .env and returns the API response back to the frontend. The Gemini API key must be valid and within quota for this to work. Admin.js. This handles admin-only operation. We check the admin flag in the database before allowing access. Admin can view all users, see platform stats like total mode entries, nodes, goals, and manage users. Now from the front-end part, we have in index.html. This is the first page users see. It has both login and registration form in our one page. User can toggle between them. When the user submits the login form, and authentication.js frontend file sends the post request to API/authentication/login to successfully store the JWT token and in local storage redirect it to the dashboard. For the dashboard, now let's dive into the dashboard. This is the dashboard. In the main page after login, it shows the username, a mood streak counter, and today's mood stats. Weekly mood chart powered by chart.js. Mood HTML. This page lets user log their mood using the emoji grid from 1 to 10. Each number has a corresponding emoji. User can also add text note below the entry from. User can see their full mood history with option and edit the note, delete the entry. Chat.js. This page displays three types of charts: the live chart, line chart showing mood over time, a bar chart showing weekly average, and a pie chart showing moods distribution, all powered by chart.js. Calendar.html, let me open it for. The calendar page shows a monthly view of mood entries each day with mood entries and colored bias on the mood structure. Goal.html. This page shows user wellness goals that with progress bars and categories levels like fitness, mental health, and or sleep. Then we have Node.js, sorry, it's .html. The sticky notes page shows colorful notes cards. User can create notes with 5 color option. Reminder.html. This page lets users see the reminder with a specific time. When the reminder times reached, a pop-up alarm appears with a sound and an option to snooze for 5 minutes or dismiss. We fixed the time snooze zone bug here by using manual date construction instead of relying on JavaScript default date phrasing. Chatbot.html. The admin panels. This is the API AI Wellness chatbot. User can type a message and get response from Google Gemini. The chat interface looks like a message app with user messages on the right and AI response on the left. Landing admin.html. The admin panel is only accessible if the user has its admin set to 1 to database. It shows platform statistics, all registered user, and allows user management. Landing HTML. Everything is same for this whole front-end file. This is the public landing page that the non-logged users see. It describes the features of the app and has buttons to log in and register. For the frontend.js, we have authentication.js. This handles all login, registration, and login on the front end. It listens it from submission, sends post request to the backend, stores the JWT token in the local storage, and redirects it to the dashboard on success. It can also handle the password I toggle feature. Dashboard.js. At the very top of this file, we have our authentic card. It checks if a token exists in the local storage. If not, the user immediately sends it to the login page. .mode.js. This handles mode, entry, submission, and displaying mood history. The It sends the mood score and node to the backend, then fetch and displays all mood history. User can edit notes and delete entries inline. Now we have chart.js. This fetch mood data and render three charts.js. We have used .destroy before rendering to prevent duplicate chart instances. This was a bug we fixed during development. Calendar.js. This builds dynamic monthly calendar. It fetches mood data and colors each day based on the mood score dates and can handle carefully using .split to avoid time zone issues and the bug we fixed. Now for the goal.js. This manages goal creation and progress updates. It calculates completion percentage and dynamic render progress bar. For Node.js, this handles creating, displaying, editing, and deleting sticky notes. Each node card is dynamic. Reminder.js. This checks the current time against the saved reminder every minute using se331, and when a match is found, it triggers an audio alarm and shows a pop-up with snooze and dismiss button. This sends the user message to our backend. For admin.js, this has a strict authentication card that checks both the token and this is the admin flag. It fetches all user platform status and renders them in admin panel. Let's dive into our CSS file. For main CSS, we have this is the main style sheet for the entire app. It defines the color scheme, typography, button styles, and many other card layers for styles. For header CSS, the style, the navigation header that appears on every page. It includes the logo, navigation links, and the logout button. For the footer, this styles the footer that appears at the bottom of every page with project information. Now let's dive into our database. We have our database run on MySQL via XAMPP, and let me show you the table we have. User table stores user information, ID, name, email, password. Moods table stores mood entities, ID, user, and goals table shows wellness goals. Notes table stores sticky notes, and reminder table for store reminders. Now let me show you our live demo. To run them, first we kill existing node presence, and this is our project, this is our dashboard, and after login we can see this present page where we have all the dashboard. You can see the mood streak, today's charts, and weekly chart. Let me go to the mood page and log today's mood. I'll select a score of out of 10 and the submitting entry appears the mood history below. Now let me check the chart.page. Here you can see the line chart, bar chart, and the pie chart all showing mood data. On the calendar page, each day with a mood entry is colored based on the score, and the goal page shows progress bars for each wellness goal. We have total goal, active goal, and compared goal. We can also select and set a goal, describe what type of goal we are going to set here, and a target date, and add a goal for this. The sticky notes pages shows colorful note cards. The reminder page lets you set time reminder, and for now let's talk about our bug we have fixed. During the development we encountered had fixed several bugs. Let me quickly go through them. First, multiple node process causing port conflicts. We fixed this by always running kill f and /in node.exe before starting our server. Second, duplicate consistent declaration causing underlying errors. Third, date showing as ISO format with the T in the middle. We fix this by using .split T and extract only the date part. Fourth, authorization token was undefined. We fix this by correctly using local storage.getThem token and passing it in the authorization barrier header. Fifth, reminder time zone issue. We fixed this by using manual data date construction. Chart.js for creating duplicate chart instance. We fixed this by calling .destroy on the existing chart before creating a new one. In conclusion, that what's our full walkthrough of the Mental Wellness Tracker project. We built a complete full-stack web application with user authentication, mood tracking, and goal setting, sticky notes and reminders, an AI chatbot, and an admin panel. The tech stack is Node.js and Express for the backend, vanilla HTML, CSS, and JavaScript for the frontend, MySQL for the database, and JWT for authentication, and Google Gemini AI for the chatbot. Thank you for watching. If you have any question, feel free to ask. Thank you.